Hello, welcome to this tutorial looking at digital circuits. In particular, in this occasion, we're looking at a full adder. Now, a full adder can be accomplished on a breadboard, or you could use a strip board, of course, but it's accomplished with using 3 TTL chips. And starting from the left, we have an XOR chip, an AND chip, and an OR chip. So we're using 3 logic gates, 3 logic chips, to achieve the circuit on this. And we have over here on the right hand side the red LED is S, or sum, and the green LED is our carry out. And we have over here we have three input buttons. We've got A, B and C in. Now the C stands for carry, so carry in. Let's think about this. If we run through the truth table with the LEDs, so if I input A, I've got 1, and we can see on the right hand side the LED is lit up. If I input B, I've got 1, so that's the binary value 1. If I input both A and B, we can see that the green LED is lit up, so that's signifying that we've got 2 in binary. So we've got 1 in binary plus 1 in binary, which of course gives us 2. Now, if I push all 3 buttons, we'll see that the red and the green LED is on, so that's telling us, of course, that we've added binary value 1, binary value 1, binary value 1. So that would give us, if we were looking at our binary table, the first 2 digits would both be switched to 1, with switch to high. Now, it's not a particularly complicated circuit, because you've got to remember to put the wires in the correct place. So if we have a quick look at the wiring here, we can see, of course, that we've got our resistors. There we go, resistors for all 3 of our inputs, and we've got our resistors over here for our LEDs, of course, and we are linking the power to our chips. So there's power to the OR gate, power to the AND gate, and power to the XOR gate. And notice that on my chips, my TTL chips with the gates, I've got a color coding system. Helps me because trying to read the numbers is near impossible sometimes. So I've got yellow for my OR chip, I've got green and a purple color for my AND chip, and I've got green for XOR. And then we can see that the inputs, or the outputs rather, and the inputs into the chips take on what looks at first like a complicated structure, but they're not. It's just so that we are carrying the values in. Okay, I'm using a USB power supply there. I'm just going to put the truth table for our full adder there in front of us, so we can see what's going on there. So we can see that if we have all of the inputs off, or low of course, then there's no outputs. But then if we have just our C in on, then that gives us a sum of 1. If we have just one of the inputs on, input B on, then that, of course, that just gives us sum of 1. If we have the input B on and carry in, or C on, then that gives us a binary value of 2, so our carry out will be 1. A on, B off, C off, of course that just gives us a sum of 1. A on, B off, C in on, that gives us a sum of a value of 2, so binary 1, 0, as we can see. We have A, B on, C in off, again binary value of 1, 0. And if we have all 3 inputs on, a binary value of 1, 1. Okay, so there we can see, and you can see, hopefully, that the outputs from A, there are 2 outputs, one there and one there. One output feeds into my XOR chip, and the other output, the other output feeds into the AND chip. Same is done with the button B. We have 2 outputs, one into the XOR chip, one into the AND chip, and then the outputs from the XOR chip, there we go, there's the output feed into the second XOR, and there's, yep, and there we go, and we can see that the output from C in is feeding into our AND chip there, and then of course it's all feeding back into, at the end, the ore chip. Well, thank you very much.